Hi, AP Calculus students. Welcome to the last section for Chapter 4. You can tell either I wear the same clothes for days in a row, or I shoot a lot of videos in one day. And this is my third, maybe my fourth video today. So in the same clothes, of course, I should probably change to mix it up a little bit. But anyway, 4.6. So this is the trapezoidal rule, and except for some tedious ideas, it's really pretty easy. It's like Riemann sums. So the trapezoidal rule estimates area like Riemann sums, right? With Riemann sums, we did rectangles, left, right, and midpoint. And the AP exam will have using trapezoids instead of rectangles. Why do we do this? Because you'll see me draw some trapezoids here to estimate this area, and you'll see why it makes sense. And in fact, when you all first did your Riemann sum sheet, remember you drew a graph and then there was water being pumped out of a tank and there was an airplane flying. Most of you logically did the trapezoidal rule, only you didn't know to call it that. So let's take a look at it. Now, number 2, let a function be continuous on a closed interval from a to b with, so let's say they are asking you for the integral from a to b of f of x dx, right? We know that that is represented by an area between that function and the x-axis, but they ask you to estimate it using the trapezoidal rule. So there is a formula for the trapezoidal rule. It's kind of crazy looking. Here it is. You would do b minus a, that would be upper limit minus lower limit, divided by 2 times the number of intervals that you have, the number of trapezoids. And you would multiply that by the first height once, 2 times the second height, 3 times the third height, right? Well, actually, so it is still 1, 2, 3 though. This is my first x, so it's labeled 0. But anyway, right, all the way to your last height, which again, you would just add your last height once. So the idea is well, what is going on here? What is this, right? How come the first height and the last height you only have once, but the other ones you have in between? So it is because we are going to go ahead and just break this area into 4 trapezoids, and you'll see that we actually end up with this formula. So you don't actually need this formula to do the trapezoidal rule. You just need to know how to find the area of trapezoids. And sometimes you can't use this formula, like on this problem here, but certainly we know how to find the area of trapezoids. Okay, so let's take a look here. Let's estimate the area, the integral from 1 to 3 of x cubed dx using 4 trapezoids. Okay, now, first of all, my cat's making a funny noise. Hold on. You okay? All right. So she's okay. So anyway, what is the formula for the area of a trapezoid? Let's just write it here. So the formula for an area of a trapezoid is 1/2 the height times the 2 bases being added, B1 and B2, right? The two, this base 1, base 2, right? The 2 sides of the trapezoid that are parallel to each other. Now, why is this true? It's true because this trapezoid is very much like a rectangle, right? It has a height, right? But it has 2 different bases. So the idea is well, let's add up the 2 bases and divide by 2. Let's find the average of the bases, right? And then multiply it by the height. And that is actually comes from the formula of a rectangle then. So it actually really makes sense that the formula for the area of a trapezoid is 1/2 the height with the 2 bases being added, because that would give the average of the 2 bases. Okay, now, so they are asking that we break this interval, right, from 1 to 3, which is 2 intervals right now, into 4. Okay, so let's go with a 1.5 here, right? And let's go with a 2.5. Okay, now the next thing I'm going to do is I like to, like with Riemann sums, collect my information. So 1 cubed is 1. 1.5 cubed is 3.375. Right, I actually don't just know that. I had done it on the calculator. 2 cubed is 8. 2.5 cubed is 15.625. And of course, 3 cubed is 27. So what I'm going to do is make 4 trapezoids. So I'm going to connect in my first interval the 2 heights together, right? So here's one base of the trapezoid, and here's the second base. Here's another trapezoid. I'm going to connect the 2 heights, right, in here and here. So that's pretty cool then. Notice that if you use rectangles, they tend to be above or below the actual function when there's a curve. But notice with the trapezoids then is because you're actually making a line on the curve, it seems like this is a pretty accurate area for an estimate here. So you can see why we would use the trapezoidal rule, right? Okay. Well, let's go ahead and just add up these 4 trapezoids, right? Let's write the area of the trapezoids, and then let's add them up. Okay, so let's take a look. So we have 1/2 for the first trapezoid. Here's the height. The base is 1/2, right? And we'll add the 2 bases together. 1 plus 3.375. Okay, second trapezoid, 1/2 part of the formula. The height between the bases is 1/2, and I'll add up the 2 bases. 3.375 plus 8. The fourth trapezoid, right? 1/2 part of the formula, 1/2 for the base, and let's see, the third 8, the bases are 8 plus 15.625. Now, I guess I'm going to kind of go into the next area here. That's okay, because it really helps to see it all in a line. The fourth trapezoid then, right, 1/2, 1/2, 1/2 part of the formula, 1/2 is the height, 15.625 plus 27. Okay, now, without a doubt, you could go ahead and do all this math, right, and get the right answer. And what you could do, is actually integrate. You know how to integrate x cubed. Now this definite integral from 1 to 3. And you could get the actual area and say, hey, did I estimate it pretty well? Please understand on the AP exam though, when they ask you to use a trapezoidal rule to estimate this integral, they know you know how to find it exactly. That is not what they want from you. You don't say, oh, I can do better than estimating. I know how to do this. That's not what they want from you. Okay, now let's take a look here. You can do every trapezoid separately. Just go through and do this math, right? But notice what's happening is in every single one of these 4 terms, I have 1/2 times 1/2, right? So I have 1/2 times 1/2. Now, notice this base of 1 is used only once in this trapezoid on the left. Notice 3.375 is used twice, right? Because it is the right base of the first trapezoid and the left base of the second. Notice that that the base of 8 is used twice in the second and the third. Notice the base of 15.625 is used twice because it is the base of two trapezoids. Notice that the last base, 27, is used once. And notice this is where the formula then comes from, right? We use the first base once, the last base once, and all the other bases we multiplied by 2 because they are in two different trapezoids. Notice that our b minus a is 3 minus 1, which is 2, right? 2, and our denominator then would be 2 times 4, right? Because we have 4 trapezoids. So we have 2 over 8, which is 1/4. Isn't that what we have right here in front? So you're welcome to use the formula, right? Certainly this was easier to write, but just so you know, if you find it confusing, you can do 4 trapezoids separately. Now, I'm not going to waste time and calculate both of these, right? Because I'm sure that you can. All you really needed to do was see the setup. Okay, now let's take a look at B. What if they give you a chart of information instead of a graph, right? Actually, I made a chart of information right here, didn't I? Here's the 0.11, 1.5, 3.3752, and 8. I kind of made myself my own chart, right? But what if you are on a road trip? Okay. And you have a certain miles per hour, and at every hour, you record the miles per hour that you're going from 1 to 12. And they want you to use the trapezoidal method, the trapezoidal rule, to estimate the difference you went between, the distance, sorry, that you went between 1 and 12 hours. Okay, so in this case, right, we kind of have to do all separate trapezoids because take a look, right? Here is, if I graphed these points out, here is the bases, right? The heights of the trapezoids. This trapezoid would have a height of 1. This one has a height of 3. This one has a height of 4, height of 1, height of 1, height of 1. And it means that you can't use this formula, right? Because you don't have a constant interval, right? For each of these. No big deal. All I'm going to do is for each one of these intervals, I am going to use, I find the area of the trapezoid to estimate it, right? Because we know area would be like a base times a height, and miles per hour times hours will give me miles. So the algebra of multiplying these two values together would give me the correct units in miles. And that is shown by the trapezoidal rule. Another thing we could do is actually make a graph. If you like a graph, you could graph these points, right? And then draw your trapezoids, right? But I'm going to go ahead and do the, right, all the areas for the trapezoids. So here we go, from 1 to 2. Okay, just picture, right, on a graph from 1 to 2, and my first base, right, the velocity is on the y-axis would be a 42, and the second base would be a 50, right? So the area of this first trapezoid right here would be 1/2, I'll call that 0.5, 1/2, right, times the height, which is 1, and I'll add the two bases together, 42 plus 50. All right, there, that would be the area for the first trapezoid to estimate the miles. Plus, now let's do from 2 to 5, right? I'll use a circle. So 2 to 5, you can see on the x-axis 2 to 5, right? And the height on the left is 50 and on the right is 48, right? So you can picture the trapezoid. Area formula for a trapezoid, 1/2 the height, and I'll add the two bases together. Okay, next, we will go from 5 to 9, right? Let's not miss any trapezoids, right? Okay. So if it's okay with you, just to save room, my third trapezoid will be here from 5 to 9. That would be 0.5. The height is 4. And the two bases are 48 and 63. Okay, that was from 5 to 9. Let's do from 9 to 10. 0.5, height of 1, 63 plus 32, plus next trapezoid from 10 to 11, 0.5, height of 1, the two bases are 32 and 50, plus last, 11 to 12, 1/2, height of 1, 50 plus 55. So when you do all of this math, right, notice that you will have the base is hours, and this is velocity. So miles per hour times hours will give you miles, right? And notice how many trapezoids we had. 1 to 2, 1, 2, 3, 4, 5, and 6, right? And I did each of the trapezoid area formulas separately because they had different heights. I couldn't just use a formula. So again, I am sure that you can do this math correctly in your calculator, right? Add it up. And that would estimate the distance that you traveled during that time period. So that is it for chapter 4. Good for you. Have a great day.